So now we're going to look at the elimination method, and we'll do one easier example and then we'll move to a slightly harder example. Okay, so notice that in both of these equations, unlike the substitution problem that we did, these all have variables raised to the same power. So we have an x squared and an x squared, and a y squared and a y squared. And when that's the case, we are going to use the process of elimination. And I've outlined the process here. We'll go through it as we go through this problem. We're going to solve this, and remember, we're looking for the place where the two graphs of these two come together. And we don't have to graph them to find that answer. So first, we line up the variables. So we've already got that. Notice x squares are lined up, y squareds are lined up, and then the constants over on the right. Okay, so that's already done. Step 2, we're going to multiply one or both equations so that we have a positive and a negative coefficient that is the same other than its sign in front of one of the variables. Now, what does that mean? It means, well, we would like to have the same number right here and right here, or right here and right here, but one of them positive and one of them negative, so that when we add them together, one of the variables goes away. And notice here, we don't have to multiply by anything. We have a positive 1y squared here, and we have a negative 1y squared here. So that's what we want. We want the same number right here, one of them positive, one of them negative, so that when we add the equations together, this variable goes away. And in this case, it's already done. We already have the positive one here, a negative one here. When we add them together, the y squares are going to cancel out. So let's go to step 3 and let's add the equations together. So I'm just going to jump in here, add a couple of spaces, and we will add these together. So if we add them together, we get 2x squared. The y squares, however, cancel because we have a positive and a negative. And then add our 25 and our 1, and we get 26. All right, now let's finish solving that. Let's divide out our 2. And we get x squared is 13. And then remember, when we use our square root principle, we have both a positive and a negative square root of 13. Now, I could put this in my calculator and actually find out what the decimal is for positive and negative square root of 13, but the truth is this one will actually be easier if we use this instead of using this whatever the decimal version is. And here's why. I can plug it into either one of these. My last step is to plug it back in, substitute it back into either equation to get the other variable. And honestly, it's going to be about the same amount of work no matter which one I choose. So I'm going to go to the top one here, and I'm going to I'll start with the positive square root of 13, right in for the x squared. Now here's why I left it as a square root. Because when I square the square root, they just cancel out and I get 13. And it just makes it a whole lot easier than putting the decimal in my calculator later and squaring that and getting something close to 13, but not quite 13. Now let's solve this for y. So let's subtract 13. And we get y squared equals 12. So y is the positive and negative square root of 12. Now we can break 12 up, and depending upon whether your exercise asks you for exact answers or decimal approximations, if they're asking you for decimal approximations, all you got to do is put the square root of 12 in your calculator. But if they ask for exact answers, we need to break this up. So let's remember that 12 is really 4 times 3. And we know the square root of 4 is 2. And we don't know the square root of 3, so it stays inside. So that's the exact answer. All right, so let's notice that we got 2 y values when we put in 1 x value. That means there's 2 points here. We have an x value of the square root of 13 and a y value of positive 2 square root of 3. And we have an x value of square root of 13 and a y value of negative 2 square root of 3. All right, now all we've done is put in the positive square root that we got here. We haven't put in the negative square root, but I want you to notice, if I put the negative square root of 13 into these parentheses, that negative will get squared, and we'll be back to exactly the same value we got right here and exactly the same two solutions. So since we know that, there's no reason to solve twice. We just know that there's another point where we have the negative square root of 13, and we get 2 square root of 3 for the y, and we have negative square root of 13 and negative 2 square root of 3. So this has 4 solutions to it. All right, now let's do one more of these. Now let's notice again that this is a system of equations that we can use elimination on. We have an x squared here and an x squared here. We have a y squared here and a y squared here. So we can use elimination. So first step, line up the variables. Let's notice they're not lined up. Y squared's not lined up with y squared. X squared's not lined up with x squared. So we're going to do that first. So I will go ahead and rewrite the top one. The bottom one I'll leave alone. So if I rewrite the top one with the x squared first, let's not forget there's a negative in front of it. And the y squared is second. And it's positive. And then I'll just rewrite the second one. Now we've got the x squared and the y squareds lined up. All right, now, just to be different, since I eliminated the y squareds in the first one, let's eliminate the x squareds, the x's this time. So let's notice that what we really want is to be able to add these x squares together and for them to disappear. There's a 3 here, so ideally if we had a negative 3 right here, when we added them together, they would cancel each other out. So what I'm going to do, in order to get a negative 3 right there, I need to multiply by positive 3, and I have to multiply my whole equation by positive 3. So that gives me negative 3x squared, 3y squared equals 27. And then I'll go ahead and just bring this other one down here. And let's add them together. So now if we add them together, our 3x squared and our negative 3x squared cancels out. Here we get 5y squared. Over here we get 35. Now let's solve that. And dividing out the 5, we get y squared equals 7. And so y is the positive and negative square root of 7. All right, now we need to go back and get our x's. It doesn't matter which one of the equations I put it in, it's going to be about the same amount of work. So I'll put the positive square root of 7 back in this first equation for y. So we'll have square root of 7 squared minus x squared equals 9. And let's solve that. So square and the square root will cancel out. We'll get just plain old 7. Take the 7 to the other side, and we get a positive 2, and multiply by a negative, and it's going to give us x squared equals negative 2. And so when we take our square root, interestingly enough, we get an answer that is actually complex number. All right, so in the real number system, this has no solution, meaning that these two never come together. Notice even if we put the negative square root of 7 in there, that would again lead us to the same thing right here. So in the real number system, there is no solution. Now in the complex number system, we could write this as positive and negative I square root of 2, and we could list out all of our points in the same way that we did the previous problem.